over problem 4 of the most recent homework. This problem has us solving a differential equation, and with this specified initial value, and then plugging in different values to calculate different pressures at different altitudes, and also to calculate an altitude at a given pressure. So to start, we're going to write our given differential equation. dP over dx is equal to negative 0.2 p. We can see here that it is a separable differential equation because you have our p term multiplied by our invisible t term. Here we can separate this differential equation by moving this dx to this side and moving this p to that side and integrate. So what we're left with is 1 over p dp is equal to negative 0.2 dx. All right. So now what we can do is we can take the integral of both sides to solve and isolate p. So we're going to take the integral here and the integral here. And what we get is ln p is equal to negative 0.2x. And we always have to remember to plus c, to add the plus c in. Okay. From here, we're going to raise both sides by e to remove this ln. And then we're also going to simplify. So the simplified version of this is going to be p is equal to e to the power of negative 0.2 x plus c. And that's also equal to, if you move this c down to, if you remove the c from the exponent and you put it into a e to the c form, because you can multiply e to the c by e to the negative 0.2x to get this, it will also equal to a e to the negative 0.2x. Where a is equal to e to the c, and it's also just a constant, just a variable. Okay, so now we have our differential equation, and we're going to actually plug in our initial value, which is p equals 0, or p of 0 is equal to 29.92. So when we have p of 0, p of 0 equals a times e to the negative 0.2x, but x is also 0, or x is 0 because of the initial parameter, and that is equal to 29.92. All right. And then here we can see that a is also just going to be, since e to the 0 is 1, we have a is equal to 29.92. So our final equation is p is equal to, or p of x is equal to 29.92 times e to the negative 0.2x. All right. Now with this equation, we can solve back and forth to get our pressure at 10,000 feet and 30,000 feet, and our pressure at, or our altitude when we are at a pressure of 15 inches of mercury. So it's important to remember units. This differential equation is giving us the pressure in inches of mercury at an altitude in miles. However, this question is asking us about feet. So to convert from feet to miles, we're just going to divide by 5280. So we divide the feet by 5280, 5,280 feet per mile, and we get the number of miles each of these are. So I'm going to quickly write those right above. 10,000 feet is roughly equal to 1 0.89 miles, and 30,000 feet is equal to 5.68 miles. All right. Now, using these two numbers, we can plug them right into our equation here and solve for p of x. So we have p of 1.89, 89, and that's going to be equal to, by just plugging this into the equation up here and putting it in your calculator, it's going to be equal to 20.49 inches of mercury, which can be written as I inches, and then mercury is Hg. We also have P of the pressure at 5.68 miles, and that's going to be equal to 9.60 inches Hg. All right. So that answers our first question, part A. That's the pressures at these feet based on our differential equation. And then with part B, we're asking for the how high, and we can use any unit, how high in miles, is it when the pressure is 15 inches of mercury. So we are going to actually set up the same equation as up here. We're just going to set this equal to our 15 inches of millimeter of mercury, and we're going to solve for x. So we have 29.92 times e to the negative 0.2x, and that's going to be equal to 15. And now solving for x, that gets us x is equal to 3.45 miles. 3.45 miles. There we go. So now we can circle all the final answers here and here. And we're done. Thank you for bearing with me. I'm sorry for my poor handwriting. I'm on a trackpad. I hope you learned something, and have a good day.